So just like DPMO, defects per million opportunities, rolled through yield is also another important parameter, important matrix which you can use when you're doing Six Sigma project. Before we understand rolled through yield, let's understand what does yield means. To understand yield, let's create a simple process. So here I have my process. Let me draw that. So that's my process. I'm doing something here in this. So this is my process. So in this process, let's say the inputs are P number of units. So P number of units go through this process, and out of that we find out that there are D number of defectives. Then how many good pieces we will be producing? So you are right, that will be P minus D. P minus D will be the good amount of units. So these are good units, these are bad units or defective units. These are total units which went through this particular process. So in this process, if I need to calculate the yield, my yield will be the good pieces divided by the total number of pieces, which is P minus D divided by P. So that will be my yield for this particular process. To understand the concept of rolled through yield, let's understand that we have number of processes if you are making something. Let's say in this particular simple example, we have three processes, process 1, process 2 and process 3. So let's draw this here. So this is my process 1, which is, let's say, P1. After that, the unit goes through another process, which is P2, the second process, and then unit goes through the third process, which is P3. So a unit comes here, the raw material comes here, and we get the finished product here. And in each of these processes, P1, P2, P3, there is a certain level of yield. We calculated yield earlier. Yield was number of good units produced by this particular process divided by total number of units which went into this process. So in this particular case, let's say we have three processes and each of these processes has a particular yield. The yield of P1 is, which is equal to Y1, is equal to 0.99 in this particular simple example. That means 99% units in the process 1 gets accepted and 1% units get rejected. Then the output of this, so let's say if we had 100 units here, 1 unit was defective, so we have now 99 units which go through process 2, and now the process 2 has a yield of 95. So Y2 is equal to 0.95. That means 95% of these units, 95% of 99 gets accepted and rest get rejected. Now that goes through process 3. Process 3 has a yield of Y3, which is equal to 0.98. Now whatever units go through P3, 98% of those gets accepted, 2% get rejected. Now if you have to calculate the rolled through yield is the total yield of the whole process P1, P2, P3. So this comes out to be Y1 multiplied by Y2 multiplied by Y3. So you multiply all the yields of the processes, that will give you the rolled through yield. So in this particular case, if I multiply 0.99, 0.95 and 0.98, that gives me the rolled through yield of 0.92169, which is roughly, let's say, 92%. So in this process where a unit has to go through P1, P2, P3 processes, that means if we put 100 units in this, we are expecting around 92 units to be accepted and 8 units to get rejected. So this is the concept of rolled through yield. So when you have number of processes, number of rejection level, you can calculate the rolled through yield of the big process or the whole chain of processes. So this was the concept of RTY or the rolled through yield.